All right, guys, hope you had a good weekend. More work with the regression lines this week. And don't forget, on Wednesday, we're going to have our first Google Meets during our class time. So look for that on Wednesday. Again, Wednesday, Google Meets, be there or be square. You have to be there. So be ready for that. Google Meets on Wednesday. All right, regression line of best fit is a sort of Scott. Don't know what just happened right there. Sorry about that. Anyway, it's also called line of best fit, which is also, when you have your data, you plot your data, you want the best line that you can possibly draw. It's called the line of best fit, which is better known as the regression line, which is really what we did last week. And your calculator comes up with that equation for you. Not that big a deal. And what we're going to do today, add to that, is we're going to punch our numbers into L1, L2, hit our scatter plot. But before we draw our scatter plot, I want you to go to y equals on your calculator. And once you get your regression line, once you get your equation, I want you to punch that equation in your y equals. And it will draw the line in your scatter plot so you can actually see how close your line is to your scatter plot, just like the picture you're looking at right now. And that's the only new thing calculator-wise that you're going to do. All right, we didn't talk a whole lot about this last week, and this is a big deal now all of a sudden. So that's what our equation is like on the calculator. Your y is actually a y hat, which means it's a predictor. It's a prediction equation. That's how the slope is calculated. We're not going to worry so much about that because your calculator gives it to you, but it's r over standard deviation of y over standard deviation of x. And that's a big deal because remember, slope really means, from your algebra classes, it means rate of change. And if you think about what standard deviation is how things vary or how things change. That's why standard deviation is used there to find the slope. All right, so slope is rate of change. Once you keep that in mind, and that's how it's calculated, even though your calculator is going to do it for you. That's how your y-intercept's calculated, but again, we don't have to worry too much about that because the technology is going to do that for you. But a big deal about the slope, rate of change. All right, so here's an example right here. Y equals ax plus b. X today, beginning today and forever, is going to be called the explanatory variable or the independent variable because we're going to use x to explain the change in y. That's what regression equations do. Y is called the response variable because it responds to the x. As you change x on this side, obviously the y is going to change also. So again, x is called the explanatory variable, y is called the response variable, or sometimes called dependent. X is independent because it does not depend on the y, but the y does depend on the x, so it's called the dependent variable. Outliers, as you would imagine, can have a very strong effect on the regression equation, especially if they're known to be errors. So when we see an outlier, we're going to make sure it is not an error. If it is there, we have to take that into account. It will affect how good our regression equation is because it makes it, it's going to make our line less accurate because it's been stretched because of an outlier. So outliers have a big impact on these regression lines and on the equations. Okay, quick example here. Have shoe print lengths, and that's my x, or my explanatory variable, and my height is my response variable. Okay, so shoe print, what a lot of police or investigators use when they find shoe prints places, they use that to come up with how tall somebody is or what their height is. So what they're saying is the value of the shoe print is used as a predictor for what the height is going to be. Okay, so I took, there's only 5 numbers in this sample, so it's probably not going to be a very great sample, but I went ahead and ran it on my calculator and got that equation. There's a scatter plot that I got, and there's the R that I got. Now the R is not that great, and if you look at the picture, the line's not that great. We got a point way up here and a point 1 down that way down there. It's not even close to that line. And so I wrote this down here. I hope you can read that. It says, talking about the slope. I'm looking right here at the type part. The slope is 1.73 centimeters. I need you to understand what this means. Remember, slope is rate of change. For every 1 centimeter change in the shoe print, we would predict a 1.73 centimeter change in the height. Remember, the x is influencing the y. The x is the explanatory variable, explains how the y gets its value. So every 1 inch change, that's what slope means. Every 1 inch change in x, the y is going to change by 1.73. That's what slope means. That's rate of change. Should learn that in algebra. This is not a good model for predicting because my R is not very strong. The picture is not very good. So this is not a very good model to use to predict things that time. Okay, here's a better example. This is the same stuff except we added 40 points instead of just the 5 we had. And look what happens when you put 40 up there. There's my new equation, a lot different from the one we just saw on the last slide. And look at my R, much better. R is 0.813, which is a lot higher than last time. Let's go through slope one more time. The slope on this equation is 3.22, which means we would predict that for every 1 centimeter change in our shoe print, that the height would increase by 3.22 centimeters, because that's the rate of change. That's the slope. We could also use the equation to predict most any height. There are a few exceptions, and that is the exceptions you're going to find out in a second are we can't go much past what is on here, like shoe print. We can't really go say, well, if somebody has a shoe print that's 65 inches or centimeters, first of all, that'd be a crazy big foot, but our prediction will not be real accurate. Or if we went way below, like our lowest one right here is probably about 25. If we went down to, like, let's say, oh, it's only 8 centimeters, probably would not be real accurate either. You got to kind of stay within those constraints of where your graph is, and also outliers can really affect it too. So that's a pretty good model right there versus the last one. All right, this is the biggest part of the day. 4 considerations when using regression. Okay, if you're going to use regression to make prediction, 4 things here that you got to really consider. Number 1, use the regression line only if the graph of the scatter plot, the graph of the line on the scatter plot confirms that the regression line fits the points pretty well. Remember what we're going to do today. I haven't shown you one of these on the video, but when you go to Zoom 9, you're going to get your scatter plot. But before you do that, I want you to, well, find your equation first today. That's going to be the difference. Go find your equation first. Go to your y equals button. Punch your equation in. You know, I think we had like 1.73x plus something earlier. Punch that in. Then hit Zoom 9, and you will see your scatter plot. And your calculator will also draw your line, and you can see for yourself how close your line is. So that's going to be the only new thing on the calculator, like I said earlier. Number 2, use the regression equation for predictions only if the linear, it is easy for me to say, linear correlation coefficient R indicates that there is a linear correlation between 2 variables. So you want your R to be strong, okay, to use an equation. If it's not, I'm going to tell you what we're going to do on the next slide, but you will need a strong R, and you want your line to be a pretty good line. All right, number 3, use the regression line for predictions only if the data do not go much beyond the scope of the available sample data. I showed you that just a second ago. Predicting too far beyond the scope is called extrapolation. Make sure you get that word down, extrapolation. If I did a shoe size, it was only 8 centimeters, or one that was 65 centimeters, that is so far away from the other points that it's called extrapolation. You're trying to predict something that the prediction is not going to be good because it's so far away from the other numbers. Number 4, if the regression equation does not appear to be useful for making predictions, so if it fails with this, if it has outliers, or the R is not strong, the line's not good, or if you're trying to go way far out, or if it just doesn't make sense to use the equation, here's what we're going to do. The best predicted value is its sample mean, meaning find the mean of your y values, and that's going to be used for the prediction. I know it sounds kind of crazy, but we're just going to find the average of the y's, find the mean. Let me show you one of those real quick. All right, this is our bad example from a minute ago. There's our picture. Here's our stats, our data down here. There's our R, which was bad. And because our R was bad and our picture was bad, in order to make a prediction, we're only going to make one prediction. Remember, we can only predict things that are within here, not outside there, because that's called extrapolation. So what you do when that's the case, when you get a bad model, what we're going to do is we're going to take these numbers on the bottom, the y's, and we are going to average them up. So I did that. I added them up. I divided by 5, and I got 177.3. But that's it. So watch for your assignment today. It's going to be on Google Classroom, be a Google Doc. Make sure you get your answers on there somehow. Turn it back into Google Classroom, and you're good for the day. And don't forget, Google Meets on Wednesday during our class time. I'll get on tomorrow's video. I'll tell you exactly, and I'll also send you a remind text. If you have not signed up for Remind, please sign up for that Remind app. If you need the code, email me or look at Google Classroom, and I'll send you the code to join that, because I'm sending lots of announcements by Remind. All right, hope you're doing great. Hope you had a good weekend. See ya.